কাজ কর, তুই চাবি নিয়ে আসতে পারবি? চাবি তোকে দেবে? তোর নাম লেখা আছে না বাবা, চাবি তো করতে হবে না এইখানে। আমি আসা পর্যন্ত যে যে অ্যাডমিট,
স্যার ডাকছে আমাকে 20 মিনিট পরে।
হ্যাঁ আমি 10 মিনিটে চলে আসবো চাবি নিয়ে। আমি আসা পর্যন্ত যে যে জয়েন করতে চাইবে তাদেরকে 8 মিনিট অ্যাডমিট করে দেবো, ঠিক আছে? আমি জাস্ট চাবিটা নিয়ে আসছি।
கஷ்டமாக இருந்துச்சு. தெரிஞ்சது மட்டும் எழுதுனேன்னு இருக்கேன், வேறு ஒன்றும் எழுதல. நர்சிங்கில் இருந்து கேட்டாங்க, ஆர்ட்லேருந்து கேட்கல.
তুই যাচ্ছিস?
பார்த்துக்கலாம் வந்து கஷ்டம் தான், எல்லாத்துக்கும் தான் கஷ்டம். தெரியாதெல்லாம் எழுதலன்னு இல்லை. நாலு மார்க்கு தப்பாக எழுதுனா மைனஸ் பண்ணுங்க.
তুই থাক চুপ। কি? তুই থাক। কেন? এইটা যখন জন্য আসবে সেটা অ্যাকসেপ্ট করবি। সে যদি
এই দুধ দিয়ে কাজ দিস না।
আরে শুধু অ্যাডমিট করতে হবে।
আমি রুম পাচ্ছি।
সে যদি আশেপাশে থাকে এক্ষুনি চলে
সেটি
যাবে।
কোথায়? কোথায় গেছে?
কখন আসবে? বললো 10 মিনিটের মধ্যে।
কি বলবো?
তুই জাস্ট অ্যাডমিট করে দিবি ওকে, যাবে ঢুকবে।
যা হবে।
কাজ দিয়ে গেল।
Am I audible?
Yes, madam, audible.
Yeah, sorry for the late because of the technical issues. I cannot join at 6. Sorry for this. Now I am starting the week 5 doubt clearance class. Uh, Actually, I cannot join the meeting with another account. Don't know what is going on. Okay, just give me 5 minutes. I will show the my screen having some problem. My screen is visible to all of you. Please confirm if the screen is
Yes, ma'am.
visible. Okay. Okay. So let's start week 5. So first we will start with the rate expression of the redox initiation. Uh, Here is the rate expression that has been discussed in your course. So Rp is the rate of polymerization, and this is Rp is Kp monomer concentration divide into Ri by 2 Kt to the power half, and Rp for redox reaction. So Rp basically the converted or reduced to this format, where Ri is equals to Kd redox sub redox substance into oxidized substance. Sorry, reduced substance and oxidized substance. So let's solve some problem with this formula so that we can have better understanding. Okay. Slightly okay. So here in this problem, Kp is given, Kt is also given, and Kd is also given. Whereas M given, M is the monomer concentration, reduced agent are present in this molarity, and oxidized agent is present in this molarity. So we have to find the M dot and Rp. So let's start with the formulas. Uh, yes. So let's start with the formulas. So we have to find Rp and M dot, and we know the formula for M dot okay, we know the formula formula for M dot is equals to Ri by 2 Kt all to the power half, or you can say root over of this. So we have to find out Ri and we have to find out Ri to evaluate M dot. Here Ri is not given, so we have to evaluate Ri first. So our formula with first we will consider what we have to find. We have to find M dot, and just read this formula and write this formula, and we have to find Rp. So for Rp is equals to Kp into M dot. Now we will look which value is given and which value is not given, so that we can proceed with the calculations. Just a minute. Hello? 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 হ্যালো হ্যালো হ্যাঁ বলুন চাবি আমি ইস্যু করিয়ে নিয়েছি চাবি ইস্যু করিয়ে নিয়েছি হ্যাঁ 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 Okay, so now Ri is not given here. Ri is not given, so we have to find out Ri, and here Kt is given, so we can easily find out M dot by finding Ri. So now next step will be finding Ri. Ri. So Ri is equals to Kd into redox concentration of reduced substance and concentration of oxidized substance. To approach any problem with kinetics of the polymerization, basically kinetics, physical chemistry of the polymerization, first write what information is given in the problem. First write that, and then find that which data you have available to which data you have available to evaluate the required data, and then find out that in that formula which data you have to produce, so that it is a retro thinking, so that you can easily understood where and when the formula will be used. then Ri is equals to Kd. Kd is 2 into 10 to the power minus 3, and the the reduced element concentration is 5 into 10 to the power minus 3, and the oxidized element concentration is also 5 into 10 to the power minus 3. So Ri is equals to comes 5 into 10 to the power minus 8 mole second inverse. So we have calculated Ri, then we can easily calculate m dot, that is 5 into 10 to the power minus 8 divided by 2 into Kt is 1 into 10 to the power 8, and this is in to the power half, and this gives you 1.58 into 10 to the power minus 8. Then here is Rp. Then we have evaluate the concentration of M radical, and that is it's very easy to calculate Rp. So just putting the formulas, Rp is equals to Kp is 300, concentration of M is 1.5, and M dot is 1.58 into 10 to the power minus 8, and this will becomes 7.11 into 10 to the power minus 6. So your answer will be this 2. This is your answer. Answer 1. Sorry, this is your answer 2, and this is your answer 1. So I am going forward to the next problem. Okay. So the next problem is Kp is given, Kt is given, Kd is also given. Monomer concentration, M concentration is 1.2, that is the monomer concentration, and the reduced element and the oxidized element concentration is given. So you have to find steady state radical concentration, that is M dot, and the rate of polymerization, that is Rp. You try it on your own. I am giving you 3 minutes of time, then I will do it for you. So in this problem, uh, same is m dot we have to calculate, and that m dot is equals to Ri divided by 2 kT whole to the power half. So Ri we don't know, so we have to calculate Ri, that is Kd reduced product concentration and oxidized product concentration, and that will give you 1.5 into 10 to the power minus 3 Kd. Reduced element is 4 into 10 to the power minus 3, and oxidized one will be 6 into 10 to the power minus 3. So Ri will be 1.50 into 10 to the power minus 8. So now m dot is equals to 1.50 into 10 to the power minus 8 divided by PKT is into 8 into 10 to the power 7, which will give you 5 which will give you 1.5 into 10 to the power minus 8. Now you have to calculate Rp. Rp is equals to Kp into m and m dot, and this will be 280 into 1.20 into 1.5 into 10 to the power minus 8, and this will give you 5.04 into 10 to the power minus 6. So this is your Rp. So going to the next problem. So here the rate constants are given, that is Kp, Kt and Kd given. Monomer concentration is also given along with the reduced and oxidized element. We have to first compute R dot and Rp. Dot and Rp, that is the steady state radical concentration, and Rp is rate of polymerization. Then you have to find out the kinetic chain length, that is nu, which is Rp by Ri. And for combination termination, compute xn, and if the monomer of the styrene has a repeat unit this, and estimate mn and estimate mn. So in the problem in your exam, this will not be supplied, this will not be supplied, this, sorry, yeah, this will not be given, and this will also not be given. Then you have to approach the problem. So for start, we have to first, sorry, we have to first calculate monomer concentration. We have to first, yes.
Ma'am, can you please show before slide?
Thank you, ma'am.
So we have to first calculate Rp. So our Rp will be, you have you just calculate the Mi. sorry, m dot. M dot will be, I am not showing the calculation. M dot will be um, 7.45 into 10 to the power minus 9. Okay, and then you have to calculate Rp, that is Kp m and m dot. So here is your Kp is 260, m is 1.3, and that is 5 into 10 to the power minus 3 and 2 into 10 to the power minus 3. So your Rp will be 2.52 into 10 to the power minus 6. Now you have to calculate the kinetic chain length, that is nu, and nu will be Rp by Ri, and this will become 2.52 into 10 to the power minus 6 divided by 1 into 10 to the power minus 8, which will give you 2.52 into 10 to the power 2. That is nearly equals to 252. It is your kinetic chain length. For combination reaction, xn will be 2 nu for combination, that is 2 into 252, and that is equals to 503. Actually it is 503.8, or like 503 will be fine. And for that, the molecular weight will be 252 into 104, that is giving you 2.61, 2.52 into 10 to the power 6. So here is the entire solution of this problem, problem number 3. You have
Madam, I have
understood?
a doubt that
Yes, yes.
yeah, that XN is 504, around 504, and in the D section of your question, you put the value 252. Why?
Okay, okay, okay. Okay, just a minute. Okay, you just take the entire value, don't take the approximation. Then its value is nu is coming 2.52 into 10 to the power 2. When we calculate the termination by combination, when we calculate the degree of polymerization, when we assume that 100% combination termination occur, no disproportionation occur, then the degree of polymerization is equals to 2 nu. 2 nu means 2 into 2.52 into sorry, into 10 to the power 2. So it will become, so it will become 503.8. So it will become 503.8, that is 2 nu, and for the molecular weight, that is Mn, it will be the degree of polymerization into the repeating unit. The degree of polymerization here is sorry, the degree of polymerization will be 503. Sorry, you are right. The degree of polymerization will be 503.2 0.8, and m will be m0 will be 104, and that will become somewhat calculation. It can become it is clear?
Yeah, sure. Yeah.
Okay. Next, we are moving forward to the anionic polymerization. Anionic polymerization is nearly similar, equals to the polymerization, the radical polymerization we have discussed in our previous classes. So next, jump to the problem. Leaving anionic polymerization without any side reaction, of 0.60 molar of styrene was initiated by 0.0012 molar of sec butyl lithium something. This is your initiator. So from the first line of the problem, we can understood that this is your monomer concentration and this is your initiator concentration. After all the styrene was polymerized, 0.03 molar of methyl methacrylate was added under perfect inner atmosphere. The degree of polymerization of styrene in the first step where MMA is not added and the number average molecular weight of the final polymer ignoring the end groups, and when MMA in this is the final polymer means after addition of the methyl methacrylate. So let's start with the problem. If no side reaction occurs, that means no disproportionation, like this will not happen, this will not happen, this will not happen. So no disproportionation occurs means each polymer chain contains one polymer chain, have only one initiator. So if one polymer chain have only one initiator, then you have monomer concentration and you have initiator concentration. So Xn will be M0 divided by I0. M0 will be your 0.60 and I0 will be your 0.0012. So the degree of polymerization will be 500. And if we calculate here the number average degree of the polymerization, that is Mn, here if we calculate 500 into 104, that is the each unit weight, that is 52666. Now the final polymer, ignoring the end groups, in the final polymer already we have add the methyl methacrylate. So we have to consider the degree of polymerization that is owned by methyl methacrylate. So and that is will be the concentration of the second monomer, that is methyl methacrylate divided by I0. Sorry, divided by I0. So MMA is 0.03, I0 will be 0.0012, that is 25. Now I am explaining why this calculation is going like this way. So I am just physically explaining your problem. Just give me a minute. If no disproportionation occurs means Im dot, in a reaction vessel we have different Im dots, if no disproportionation occurs, that is no combination occurs, that is Im dot plus Im dot will give you Imm I. If this is not occurred, then we can say that each initiator molecule will have the polymer chain, the growing polymer chain, one polymer chain contains one initiator molecules. One polymer chain contains one initiator molecule. So number of polymer chains will be the number of initiator molecules. So that's why Xn comes into the picture, that is I0 we have I0 because Xn, so that it becomes M0 by I0. Okay, and then after that addition of methyl methacrylate, say I am adding 12 number of methyl methacrylate. So 12 number of methyl methacrylate, if it add into the reaction mixture, then see we have only 3 growing polymer chain. So it should be distributed like what? It should be distributed like we have 12, and it should be distributed how the how with the initiator growing polymer chain. So we have 12 methyl methacrylate, and methyl methacrylate we are considering equally distributed with the polymer chain. So if methyl methacrylate is equally distributed the polymer chain, then the methyl methacrylate chain length will be, we have 12 methyl methacrylate and we have only 3 growing polymer chains. So each polymer chain contains 4 consecutive units of methyl methacrylate. So here the 3 is the number of the polymer chain. We previously would say that the number of polymer chains is equal to the number of initiator molecule, because each polymer chain contains one initiator molecule. So it can be so we can say that it becomes I0, and this is the concentration of the added MMA. So we have put the concentration of MMA. So in this case, now in this case we have also calculated the degree of polymerization. So the entire polymer molecular weight will be, that is 52000 will be fine, along with 25 into 100. 100 is the M repeating unit weight. So this will become 54500. Okay. So this problem is clear to all of you, or otherwise I will explain it more. This is clear? Initiator unit taken, same value for both. Yes, initiator unit taken, same value for both. If, this is because, as I have said, that initially the initiator attached to the growing polymer molecule and no combination occurs. So one initiator molecule contains one polymer chain. So in both cases we are considering the initial concentration of the I0. Any other questions?
Ma'am, show previous slide, ma'am.
Previous slide. Okay. week
Ma'am,
5.
one more question. For all living anionic polymerization, is it like that, or for specifically without any side reaction, it is showing like that? That is
Sorry, I am. Your voice is not coming clearly. Please repeat.
For all living anionic polymerizations, the questions means we should answer like this. Means with the without any coupling, it should go like this. Or for this specific question, if it is showing that without any side reaction, we should go like this. For all anionic polymerization, like this only.
Yes, it will only for without side reaction. Then it is yes.
Okay, ma'am. Understood.
Then it is yes.
Understood.
Next question. Oh God. Okay. Do you have any other question? Someone posed some question and now I can't find out that. Okay, I'm going to the next one. If you have question, you can send me. If you have question and cannot ask in the class, you can send me your doubts in my mail, personal mail ID. I will answer. I will try to answer of your doubts. So next is a living polymerization, living anionic polymerization. Then also without side reaction of 0.40 molar isoprene was initiated by N-butyl lithium. After all the isoprene was polymerized, this styrene was added to the perfect inner atmosphere. The degree of polymerization of isoprene in the first step before addition of styrene and the final weight of the polymer. Okay, someone asked me why I multiply 100. Yes, 100 is the methyl methacrylate weight. Methyl methacrylate molecular weight is 100. So 25 methyl methacrylate unit will join to the each polymer molecules. So 25 into the molecular weight of the one unit. So I have multiply here 100.
I have a doubt whether you are going to provide this molecular weight during the exam or not.
No, molecular weight.
You will not provide.
No, molecular weight I think will not. They will not provide.
Let's say isoprene or like you give any unknown kind of thing. Then what is the
See,
what I'm supposed to do?
I think in your exam, the molecule will be given like the common ones, styrene, isoprene, like methyl methacrylate, acrylonitrile. These molecules will be given. The molecule that has already discussed in your lectures, in your Professor Dibakar Dhara's lecture, you can just only remember the molecular weight of that. That will be sufficient for your exam.
Okay, okay, okay. Thank you.
Okay, just try this problem. Mm, try this problem, and I am giving you 3 minutes. solve this one. Okay. So I0 here is equals to 0.0020, and M0 is isoprene. This is 0.4 molar. So the degree of polymerization xn will be isoprene polymerization 200, right? And the molecular weight I think you are not right, but the isoprene is correct. So let's see. I can also do mistakes. So let's see what will come in. M0 by I0, that is 0.4 divided by 0, that is equals to 200. Now molecular weight ignoring the end group after addition of the what styrene. So degree of polymerization with styrene will be 0.1, this is 0.008, that is equals to 50. Now we have to calculate the molecular weight. Mn, that is number average molecular weight. Main polymer molecular weight is 200. So degree of polymerization is 200, and the molecular weight of isoprene is 68. 1 unit molecular weight of isoprene is 68, whereas styrene molecular weight is 104. So this will give you 18800. I am checking the answer because we have discrepancies. Yes, answer will be 18800. Yes, 18800. Good. Next one. So this is the problem I have picked it up from the previous year assignment. So this is the problem of a previous year assignment. So let's start the problem. You approach the problem. I am giving you 3 minutes. After that, I will solve it. is 500. You are right. 27500. It just becomes 27530 actually. So just check your calculation once. Don't take any approximation. So next, after addition of the methyl methacrylate, the degree of polymerization of methyl methacrylate will be that will be 10. Now the entire molecular weight, that is Mn number average, it is 500 into acrylonitrile is 53.6. 27500 will be okay. You can take here 53.6 plus it will becomes 10 into 100 equals to 275. My answer is coming 31. Probably I am taking this approximation, so my answer is coming like this. Also 27500 to 27550 will be the accepted answer. Will be the accepted answer. So your answer is correct. So moving to the next problem. This is your week 4 assignment. Assignment of week 4, the question number 7 and 8. Question number 7 and 8, I am showing you how okay, this is the same problem with the previous one. Yeah, this is the same problem like the previous one. So please ignore it. Okay, now week 4 assignment question 9 and 10. Say that consider the following reactivity ratio of the copolymerization of monomer pair, that is P and Q. P and Q is your monomers and the reactivity ratio are given. So reactivity ratio depend upon the reactivity ratio in condensation polymerization. The nature of the polymer can be determined. So assume the polymer sample is isolated at low conversion and feed ratio is 1:2, and this will be at low conversion, in which case the possibility of getting two homopolymer will be maximum. Homopolymer when homopolymer means like only P blocks, P blocks. So homopolymer means where the reactivity ratio either P is very greater than 1, either P or Q. Because if Q has a very high reactivity ratio, then P that is also give rise to the Q like homopolymers. So in this case 0.5 to 1, no, 0.4 to 0.1. Let's see bigger than this number is available or not. No, bigger than this number is not available. So your correct answer is B, in which case copolymer composition will be same as the feed composition. It has discussed with you in the lecture series, that is when R1 and R2 is equals to 1, then it is the condition of the azeotropic composition. So here is a problem like that. You have tried it. I am giving you 2 minutes of time.
Ma'am, please show the previous slide, please.
Is it fine? Can I move to the next slide?
Yes, ma'am.
Ma'am, previous slide show me. Ma'am. Answer is ninth question. Answer is correct one is D answer, ma'am.
Yes, correct one is D.
Ninth one is D, and tenth one is D answer. Yes, okay. Thank you.
Madam, please go to the previous slide. I have a doubt. Your feed ratio is 1 is to 2, and your in the case of C option, your reactivity is like 1 is to 2. So why for the question number 10, why don't you think that C is not the better option compared to your R1 is R1 and R2 equal to 1? Because that will nullify your this gain. If I multiply the feed ratio and this reactivity, I think it will be give a better alternative
If you multiply the feed ratio and
with your
reactivity,
reactivity.
then
Yeah,
it will give
reactivity.
you 1 is to 4. See?
No, 1 is to 4 not. This oh sorry. If it is 2 is to 1, then what was the case?
Reactivity. What do you mean by a reactivity?
Yeah.
Reactivity 1 1 divided by means the tendency of forming homopolymer and tendency of forming copolymer. This question not accepted answer is D. Question 9 I think accepted answer is D.
No, ma'am. Answer is correct answer is D, madam.
Question
Number 9, ma'am. Question number
accepted
9.
answer is D. Okay, okay. I will say consider that and I will let you know what happens here. Now I'm explaining this one. That is R1 is K11 by K12. That is the tendency of forming homopolymers divided by tendency of the forming of the copolymer. And for R2, it will also, that is the K22 and K12. If R1 and R2 is the same, so you have R1 and R2 is the same, so you have a equal probability of uh, forming homopolymer and forming copolymer. So if uh, then if R1 and R2 is same, then if you have the equal probability of forming homopolymer and copolymer. So this will give you a exact azeotropic mixture. Azeotropic mixture means it is a critical concentration where the probability of the both of the reaction is same. So as the reactivity ratio determines the reaction type, so when R1 and R2 both are 1, then it will give give you the answer. And I think it follows the Lewis-Mau equation, something like that. There is a formula. Okay, I will share it with you. There is a possible formula by which we can calculate uh, by which we can calculate when azeotropic composition is occurs. I will share with you the formula. Now I don't have the formula. Now I have to.
So
Yes.
it is independent of feed ratio.
It is independent of the feed ratio. According to your lecture slide, it is independent of the feed ratio, but with according to the the formula, sometimes it differs. So it is a confusion.
Okay.
I'm just want to telling you, it is a confusion. You can raise a query to the NPTEL portal because Mayo-Lewis equation is says something different. Okay, and I will.
Ma'am, 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 suggestion, ma'am. Before submit the assignment date, you solve the questions, problem solving session before the submit the assignment, ma'am. After that, my last my
Sorry.
answers are incorrect answer.
Yes, yes. I am instructed to solve the problem
Assignment
before.
answer is tell me.
What you are saying, I am not getting your point. I am not getting your point.
Ma'am,
Hello. Let me check the answer of that question. It the question number is 9 and 10. Correct answer is B in the answer sheet, but the accepted answer will be different. Okay, raise a query. There is a serious problem. I'm I'm showing to you. Just give me a minute. Okay. Here, both the answer accepted answer is D, but here also shared a assignment solution thing. When we go to the assignment solution, you can see the correct for 9 correct answer is B, and for 10 correct answer is D. Is it visible to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, organize the problem solving session. The assignment submission last day. I can't do that. I know if I do the problem solving session, like similar problem solved with you, the assignment will be easier. do that.
Yes, ma'am.
Previously,
Yes, ma'am.
previously I am starting like that. Okay, just discuss the problems of the assignment that you have to solve. But I have instructed not to do that. I have instructed not to do that until your answers are released. I cannot discuss with you the problems and the similar problems like that. So, but no answer came. So in that case, I don't think I can do anything, because I also raise query and I also do the email. But they said that only students can raise query. TA can not raise query, and the problem solving, I cannot share with you the problems that are in the similar problems in the coming assignment. That's my hands are tied. So I'm just discuss with you after the results released. I can understand your problem. I can understand, but I'm not able to discuss.
Ma'am? But the assignment problems are really difficult, ma'am. Seriously, because the lecture we all only they are giving the lectures, but there is no session called problem solving and all. If we are going for any notes, also we are not getting proper notes based on this kind of problems and all, ma'am. Only your session is very much helpful for us. Seriously.
So
But we don't know how to get the full marks in the assignment. We don't know, ma'am, serious.
I
Because
understand.
in the fifth week, the problems are really difficult, ma'am. Fifth week, we can't even touch few questions. Likewise, it is there, ma'am.
Okay, I will bring your concern to the NPTEL team, and I have your query. I will
Thank you, ma'am.
please
Ma'am, the
please
lectures and the questions that are coming in the assignment are very different. Yes.
I agree with you. I have listened your concern, and I have brought your attention but similar problems basically similar problems in the 15th week. Solving similar problems in the fifth week, and it can be if I get permission from the NPTEL team. If they permit me via email, then I can give you classes that, or I cannot. I cannot promise you anything.
But we are having the only hope is you only, ma'am. Because for the exams also, we are trusting only this problem solving session, nothing else.
Okay, I will
The
explain
way
you.
you are saying the problem, you are saying very, very clearly the problem.
Last date of week 5
Ma'am.
assignment is the. Yes, tell me.
Ma'am, my opinion, ma'am. Online courses topic is introduction to polymer science, ma'am. But you have to given so many problems in assignment questions, ma'am. Only theory is enough, ma'am. A lot of problems are given, ma'am, in assignments. Uh, Only 8 weeks are there.
So bigger.
So already, so this is difficult, ma'am. Introduction to polymer science only for theory, ma'am. So many problems are given, ma'am.
This is more.
This is my opinion.
More like kinetics of polymerization.
Okay, ma'am.
I am not saying this is
Myself
easy.
studied myself studies only for introduction to polymer science, ma'am. Basic. polymerization? What are the type of polymerization? Different types and then naming reactions are there.
Okay. Yeah, this is so you have to polymer science, and I agree that. So they are discussing more about kinetics of polymerization. It's actually kinetics of polymerization. The
Okay.
kinetics part is quite difficult. I agree that, but I am just a TA, so my hand is tied. The tomorrow is the last date of the week 5 assignment, so I can't do anything with week 5 assignment. I will try to do with week 6 assignment so that you can able to solve that. I can try to do that. Otherwise, I will
Okay.
do it tomorrow. They want to answer with tomorrow's second half or like that. It is not possible to arrange a class tomorrow. Okay. Okay. Next, go to the next problem. Okay. Consider the following reactivity ratios of. Okay. This is the problem. Uh, Consider the following reactivity ratios for the. This problem is coming in your previous year assignment. Assume the polymer isolated at no low conversion M1 M1 M2 is 1 is to 2. Specify the type of copolymer, random, alternating, and block. Which polymer will. Okay. Hmm. So for this, the first option, that is R of M. I am writing R of M instead of R1 so that you have better will the you will understand better. And R of N equals to 0. So what does it means? It means that reactivity towards M and reactivity of M towards N is 0. And it only becomes when K of mm is equals to 0. Because to have this equation a 0 value, this will be this have to 0, and then the entire equation will be 0 value. So the significance is K of is 0. So the tendency the, the tendency of the m dot react with m dot is is 0. Tendency is 0. So m dot is forced to react with n dot and form m n dot. Now similarly for n, similarly for n, n will also be 0. So n dot cannot have any activities towards n dot. N dot will always react with m dot. So if this happens, then m and n combines to give m n dot. Then now n dot is the reactive radical. It will react with another m dot, and this will give you m n m. And now m dot is coming. Now this will react with another n dot. So it is a situation of the perfect alternating copolymerization. Is it clear? I think it will be clear. It is a easy problem.
Yes, ma'am.
The mole fraction of m in the product of 4. In the product of 4, 4 means R of 1 is equals to 1 and R of 2 is equals to 1. Okay. Then we have to, as the mole fraction of the m in the product. So mole fraction will be, feed ratio is m1 is to m2 is 1 is to 2. Then the mole fraction will be m1 mole fraction will be 1 by 1 plus 2, that is 1 by 3, and that is m2 is this is the mole fraction of the product. I think M is asking. Just a minute. It will not N. It will be M. So M is 1 by 3, that is nearly comes 0.33. Next is a raft polymerization. Raft polymerization is new in polymerization industry, raft polymerization. So this is actually the formula of raft polymerization. I am telling you, just remember this one. Just remember this one. This one will solve your problem. You don't need to understand each and everything. This will be sufficient if you have a problem understanding this raft polymerization. This equation will do your job. So raft 1. So for a raft polymerization is carried out using 2 mole of methyl methacrylate. Very good. 2 mole of methyl methacrylate. The raft polymerization is carried out. Matlab initially 2 moles of methyl methacrylate, that is methyl methacrylate is your M0, and 0.005 mole of chain transfer agent. Chain transfer agent matlab CTA. In raft polymerization, chain transfer agent is this raft agent is actually the chain transfer agent. This is actually CTA, chain transfer agent concentration. So this is chain transfer agent concentration. It was found that 50% monomer has reacted, that is P equals to 0.5. Find the average polymerization and molecular weight of the polymer. Okay, let's go to the formula. Formula A is XNPM0 by CTA. So formula will be Xn equals to M0 divided by CTA. This is 0.5. M0 is 2 and CTA is, and this will becomes 200. Now methyl methacrylate molecular weight is 100. Methyl methacrylate molecular weight is 100. So the molecular weight of the polymer is equals to 200 into 100, will give you 2000. Okay. This problem is clear. Can I move to the next one?
Yes, ma'am.
Try this problem.
Then is 60, ma'am. And then molecular weight is 7,680, ma'am.